Right, today I'm going to show you some integration. More specifically, I'm going to show you how to integrate ln, also known as ln. We always say that ln cannot be integrated. And to be fair, it can't by normal methods. There is no automatic integral. But this is what it does have. If I rewrite this, and like I said before, and like I keep on saying, manipulation is key. Anyone can do sums, they just need practice. It takes a true mathematician to be able to manipulate his equations so it works. So, I know that I can integrate this by parts, and normally they will be nice and tell you. So I know it'll be ln x multiplied by 1. Or if I want, I can do like 2 ln x multiplied by a half. It doesn't really matter. You should try that, see if your examiner's awake when he's marking it. Right, so here, what you have, picking U and picking V for integration by parts. If you're not sure how to do integration by parts, I have a video up about it, and just go and click on it. And it'd probably be better looking at that before you listen to this. As we know, we need a U and we need a dv over dx. The thing is, I can't integrate ln x. Weirdly enough, seeing I'm doing integration on ln x. So I choose 1 to be the one that I actually integrate. This is kind of counterintuitive because we always taught to try and reduce instead of bring up. But you'll see how it works out. So my dv by dx will be 1, so my v will be x. Now, that naturally means that my u equals my ln x. So my du dx equals 1 over x. Now I do see what I'm going with. So therefore, my integration turns into this. Oops. Let's go right formula there. X ln x minus that multiplied by that. What's x multiplied by 1 over x? 1. Giving me a lovely answer of x ln x yeah, I know, it's lovely. What is even better about this is you can adapt it. And Sia did this a few years back, where they give this as the opening question. Then the second question was, what happens if it was x ln x? And the question after that was, what happens if it's x squared ln x? But and the thing is, a lot of people did the question again just for them. But this is where understanding comes in again. You should know what an x squared would affect. So what an x would affect. So let's say it's integration of x ln x. Okay? So I know if that was the case, then my dv by dx would be x, and that my v would be x squared over 2, right? So I don't have to do the whole thing again, I just have to put those in. So I know that the answer would be x squared over 2, then x, minus the integral of x dx. And actually, that would go to x squared over 2 ln x minus x squared over 2 plus c, of course. And naturally doing it with that being a square is just the same, really. And if you notice, there's actually a pattern for this. And the pattern for the answer, you should never use patterns, by the way. Just mentioning this, you should not use patterns. You should not remember patterns, you should remember methods how to do something. The pattern would be x to the n plus 1 over that to the plus 1 upon ln x minus 1. So what I'm saying there, by the way, this pattern only works, as far as I'm aware, because I haven't tried it otherwise, only works for n greater than 0. Greater than or equal to 0. And actually I also haven't tried it for n as an integer as well. Right. And obviously you've got to have a plus c up here. But there is a pattern there. So you could say that ln can be integrated then. But the reason why we say it can't be integrated is because this is only for the specific scenario, or the set of specific scenarios. And you could be given something else. The exam was always looking for new questions to try and push students, to try and see what they can ask.